Well, that did it. After the last journal to reject my paper, I decided to build a functional prototype Wi-Fi USB antenna with the help of this 3D printed part from the TechPro group in LA, so I could then send it out to an independent lab for testing as proof of concept of its new physics. It's my first physics experiment, and it's a huge success. Let's look at that 3D pattern. No freaking side lobes. Now I can take it right to production using some of the most advanced multi-layered PCBs to replace the single-layer PCBs of the prototype shown here, so that this Kickstarter project reward is expected to test as the highest performance antenna in the world, including higher performance than even NASA's deep space satellite antennas. The tighter CNC tolerances over the manual machining and hand soldering of the prototype are guaranteed to further focus the frontal lobe more directionally, meaning higher gain with a laser-like coherence along the z-axis, so that the more signal power is applied, the greater number of coherent, linear, in-phase, identical spin photons will be generated. So Kickstarters were ready for production. Already have a name for it. Since the results came back positive, I've named it the Lauren Antenna, which, as Lauren is demonstrating, attaches to the bare extender USB gadget, replacing its rubber ducky antenna. So now you gotta meet Lauren, right? Well, here she is. Hi, Lauren.
Hi, David. Well, I'm very pleased with your part. Initially when Mark and I evaluated your file, we really weren't sure if printing this from the Stratasys 3D printer was going to be a good fit for your application. But I'm glad that you came to visit us recently at our open house and convinced us to give it a try. And after running the part and you doing the test, we were just so elated to hear that you had great success with it.
Yeah, it was a huge success. Just looking at the 3D pattern, I realized I had proof of concept, and taking it to full production with fully made out of a 3D printer with conductive and dielectric layers, which is something that I can do. I can develop that. And cut. Okay. Clearly, I'm not an actor.
We should probably talk more into the camera, huh?
Yeah. Anyway, there's been a change in plans. First, the project is going to focus on breaking the world record for directional gain using multi-layer PCBs.
So that's what this Kickstarter project is about.
Right, yeah, exactly. Starting with this Wi-Fi 2.4 gigahertz band, the patent pending is continuously scalable from the very high frequencies to the tremendously high frequencies, and it'll provide higher signal-to-noise ratio, meaning more useful information for medical materials and ground-penetrating radar scanning, spectroscopy, and improvements in X-band satellite communications.
Great. Well, I had heard about Kickstarter through some business associates, and I guess one of the big appeals of it is that it allows people to be part of a creative process. And not only would it wouldn't be just owning like a gizmo or a gadget, but they could be part of scientific history, and I think that's pretty amazing.
Yeah, it's a new millennium, new year, a new millennium. So we just need some global Kickstarter creators to make it happen, to put the fun back in funding.
Great. Well, we definitely took a chance on your product by printing it through the Stratasys 3D printer, and I hope that everybody else takes a chance to and may experience the same success
I'm so
that we
glad
did.
you did.
Thank you, David.